Okay, earlier we dealt with functions that were positive when we found area under that curve. But is there a way for area to be negative when we calculate it? How could area be negative? We're multiplying a positive times a positive. It's going to be positive. But there's two ways that we could actually get area that's negative. Well, one way is if f of x is negative. Or d of x could be negative. So what would it look like if f of x was negative? Well, that would mean that our graph is actually under the x-axis. Notice that all of our f of x's, our y values, are negative. So the area under this curve would be actually negative because we have negative y values. How could dx be negative? Well, that would mean that instead of going from A to B, we went from B to A. We're calculating it backwards. So what would happen if both of them were negative? Negative times a negative would give us a positive. So often we refer to the integral not just as area, but as net area. For example, if we had the graph of sine x, the areas of the two regions are shown. This one would be a positive 2. This one would technically be a negative 2. So the net area would be 0. Now on the next page, we're going to estimate what's going to happen for each of these integrals. 0 to 2 pi. Well, we just talked about that. The net area would be 0. But what if I went from pi to 0, going backwards on that top piece? Let me zoom out a little bit here. There we go. If I went backwards, I'd be measuring it backwards. That would give me a negative dx, and I would come out with negative 2. Now what about from pi to 2 pi? My f of x is negative, so that would also be a negative 2. What about from 2 pi to pi? So we're going backwards when f of x is already negative. Negative times a negative is going to give me a positive. Pi over 2 to pi over 2. Well, that's interesting. Pi over 2 to pi over 2, we're not going anywhere. That's a width of 0, so the area would be 0. Now notice the difference on this one. 0 to 2 pi, so we're going, our dx's are all going to be positive, of the absolute value of sine x. So that would mean that we would reverse all of our negatives and they'd all be positive. So that would flip this side of our sine function, and so we'd have a positive 2 here and a positive 2 here. That would give us a 4. But what if we reverse that? The absolute value is on the outside. That means we're going to find the area and then take the absolute value. So what is the area from pi to 2 pi? It's below the curve, so that's negative 2. Then take the absolute value, and we would get a positive 2. What do you think would happen if we extended the graph to 3 pi? Well, to pi was 2. Here's 2 pi. So 3 pi would be another positive 2. So we'd have a positive 2, a positive 2, and a negative 2. That leaves me with positive 2. And the absolute value of positive 2 is just 2. What about if we go the other direction and go to negative pi this way? So negative pi all the way to 2 pi. Well, this side would have been negative 2, positive 2, and another negative 2. That would give me negative 2. What if I go backwards and go from 2 pi back to negative pi? That's going to reverse it and make it a positive 2. What about 3 pi to 0? So starting over here and going backwards. Well, if we went forwards, we got a positive 2. So going backwards would be a negative 2. What do you think it would be 0 to 10 pi of the absolute value of sine x? Now remember, absolute value of sine x means that all of our f of x's would be positive, right? 0 to pi was 2. So every pi is going to give us an area of 2, positive 2's, because this is an absolute value. So positive 2 for each of those pi's would give me 10 positive 2's, which would be 20. If you'd like to check to see if you kind of got the idea, go ahead and check with the next graph. You can pause the video and then restart it. If you're still unsure, then you can follow along. -4 to -2. We want to find the area under that curve. When I draw in on my picture, I end up with a nice trapezoid. Trapezoid is the average of the bases times the height, and it's positive because we're over the x-axis, so it's 2 wide. Base 1 is 1, base 2 is 3, divided by 2. It's going to give me 4. So the area right here is 4. What about from -1 to 1? -1 to 1. We have a semicircle with a radius of 1, and it's negative. So it's going to be negative half of pi r squared. The radius is 1. So that's going to be negative pi over 2. I'm going to go ahead and write that in. From here to here is negative pi over 2. What about from 0 all the way to 3? Well, from 0 to 1 would be half of that, so that would be negative pi over 4. And then we have this triangle, which is negative. Triangle is half of base times height. That'd be 2 and 1. Now remember, the reason it's negative is because technically this height is a -1. So that gives me -1 minus pi over 4 be negative 5 pi over 4. All right, 3 to 1. Remember, this is reverse, so that's reversing our dx's. That's making dx negative. But f of x was already negative. So this is going to reverse this area, which we said that was -1. If I reverse that area, it becomes a +1. What would happen if I went from 1 to -1? Reversing it would turn it positive and make this a positive pi over 2. What about -1 to -4? Oh, we haven't found the area of this little piece. We probably need to. That's a triangle, so 1/2 base times height. Base is 1, height is 3, so this would be 3/2. If I went from -1 to -4, since I'm going backwards, these originally were positive, those are going to turn them negative. So I'd have this area plus this area. But I'm going to make them negative because I'm reversing the direction. 4 plus 3 halves, that'd be 8 halves, 11 halves, negative 11 halves. What about from negative 4 all the way to 1? Okay, now notice the direction of our integral is positive, so we're looking at the positive x values. So we're just going to add up everything under the curve from negative 4 to 1. The first is the trapezoid, 4, 3 halves. Then we have this negative piece. So this ended up giving us 11 halves minus pi over 2. What if I reverse the direction? That would make this negative, and this positive. So that'd be negative 11 halves plus pi over 2. Negative 4 to 3. That'd be everything, and it's going in order. So we're just going to add up all those areas. 4 plus 3 halves was 11 halves. We had negative pi over 2 and a negative 1. Well, I can combine those. That's 2 over 2, right? So that'd be 9 halves minus pi over 2. What changes when I take the absolute value of f of x? We're going in order from negative 4 to 3, but this time we're going to make all the f of x's positive. That's going to make all the areas positive. So I'd start at 11 halves. It was already positive. But now we're going to add pi over 2 and then add the 1. That gives me 13 halves plus pi over 2. What's the difference if I'm going from 3 to negative 4? So I'm reversing my direction, but f of x's are all original values. That means instead of this being a negative 1, it's going to be a positive 1. It's going to be a positive pi over 2, and these would become negative. It basically reverses the signs that we had here. So what would happen if we reversed it on the absolute value one? Well, it's just going to become negative version of that. The next video is going to look at particle motion as it applies to integrals.